Chapter 3 Atoms and Molecules Question Answers from Class 9 Subject Science. Page 27 Questions. Question 1. In a reaction, 5.3 gram of sodium carbonate reacted with 6 gram of acetic acid. The products were 2.2 gram of carbon dioxide, 0.9 gram water and 8.2 gram of sodium acetate. Show that these observations are in agreement with the law of conservation of mass. Sodium carbonate plus acetic acid gives sodium acetate plus carbon dioxide plus water. Answer: sodium carbonate 5.3 gram, acetic acid 6 gram, sodium acetate 8.2 gram, carbon dioxide 2.2 gram, water 0.9 gram. As per the law of conservation of mass, the total mass of reactants must be equal to the total mass of products. As per the above reaction, left hand side is equal to right hand side, that is 5.3 gram plus 6 gram is equal to 2.2 gram plus 0.9 gram plus 8.2 gram is equal to 11.3 gram. Hence, the observations are in agreement with the law of conservation of mass. Question 2. Hydrogen and oxygen combine in a ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? Answer: we know hydrogen and water mix in a ratio 1:8. For every 1 gram of hydrogen, it is 8 gram of oxygen. Therefore, for 3 gram of hydrogen, the quantity of oxygen is equal to 3 multiplied by 8 is equal to 24 gram. Hence, 24 gram of oxygen would be required for the complete reaction with 3 gram of hydrogen gas. Question 3. Which postulate of Dalton's atomic theory is the result of the law of conservation of mass? Answer: the relative number and types of atoms are constant in a given composition, says Dalton's atomic theory, which is based on the rule of conservation of mass. Atoms cannot be created nor be destroyed in a chemical reaction. Question 4. Which postulate of Dalton's atomic theory can explain the law of definite proportions? Answer: the postulate of Dalton's atomic theory that can explain the law of definite proportions is that the relative number and kinds of atoms are equal in given compounds. Page 30. Questions. Question 1. Define the atomic mass unit. Answer: an atomic mass unit is a unit of mass used to express the weights of atoms and molecules, where one atomic mass is equal to 1 by 12th the mass of one carbon 12 atom. Question 2. Why is it not possible to see an atom with the naked eyes? Answer: firstly, atoms are minuscule in nature, measured in nanometers. Secondly, except for atoms of noble gases, they do not exist independently. Hence, an atom cannot be visible to the naked eyes. Page 34. Questions. Question 1. Write down the formula of first sodium oxide. Answer: Na2O. Second, aluminium chloride AlCl3. Third, sodium sulfide Na2S. Fourth, magnesium hydroxide MgOH2. Question 2. Write down the names of compounds represented by the following formulae. First, Al2SO4 aluminium sulfate. Second, CaCl2 calcium chloride. Third, K2SO4 potassium sulfate. Fourth, KNO3 potassium nitrate. Fifth, CaCO3 calcium carbonate. Question 3. What is meant by the term chemical formula? Answer: chemical formulas are used to describe the different types of atoms and their numbers in a compound or element. Each element's atoms are symbolized by one or two letters, a collection of chemical symbols that depicts the elements that make up a compound and their quantities. For example, the chemical formula of hydrochloric acid is HCl. Question 4. How many atoms are present in a first H2S molecule? H2S molecule has 2 atoms of hydrogen and 1 atom of sulfur, hence 3 atoms in total. Second, PO4 3 negative ion. PO4 3 negative ion has 1 atom of phosphorus and 4 atoms of oxygen hence 5 atoms in total. Page 35 questions. Question 1. Calculate the molecular masses of first H2. Answer. So for reference I have written here atomic mass of carbon C is equal to 12, hydrogen H is equal to 1, chlorine 35.5, O oxygen 16. The molecular mass of H2 is 2 into atoms atomic mass of H, that is hydrogen, is equal to 2 into 1 because atomic mass of hydrogen is 1 and there are 2 atoms, so 2 into 1 is equal to 2 unit. Second, O2. The molecular mass of O2 oxygen is equal to 2 into atoms atomic mass of oxygen is equal to 2 into 16 because atomic mass of oxygen is 16 and there are 2 atoms of oxygen, so this is 2 into 16 is equal to 32 unit. Next, Cl2. The molecular mass of chlorine Cl2 is equal to 2 into atoms atomic mass of chlorine is equal to 2 into 35.5 unit because atomic mass of chlorine is 35.5 and there are 2 atoms in chlorine, so 2 into 35.5 is equal to 71 unit. Next, CO2. The molecular mass of CO2 is equal to atomic mass of carbon plus 2 into atomic mass of oxygen because there is only one atom of carbon and 2 atoms of oxygen, and we know atomic mass of carbon is 12 and for oxygen is 16. So 12 plus 2 into 16 is equal to 44 unit. Next, CH4. The molecular mass of methane CH4 is equal to atomic mass of C plus 4 into atomic mass of hydrogen because here there is only one carbon atom and 4 hydrogen atoms, and we know atomic mass of carbon is 12 and for hydrogen is 1. So 12 plus 4 into 1 is equal to 16 unit. So here in the reference I have written for nitrogen is equal to 14. C2H6. The molecular mass of C2H6 is equal to 2 into atomic mass of carbon plus 6 into atomic mass of hydrogen because here there are 2 atoms in the carbon and 6 atoms in hydrogen. So 2 into 12 plus 6 into 1 is equal to 24 plus 6 is equal to 30 unit. Next, C2H4. The molecular mass of C2H4 is equal to 2 into atomic mass of carbon plus 4 into atomic mass of hydrogen. Here there are 2 atoms of carbon and 4 atoms of hydrogen in C2H4, and we know atomic mass of carbon is 12 and for hydrogen is 1. So 2 into 12 plus 4 into 1 is equal to, this is 24 and this is 4, and finally 28 unit. Next, NH3. The molecular mass of ammonia, atomic mass of nitrogen plus 3 into atomic mass of hydrogen because here there is only one atom of nitrogen and 3 atoms of hydrogen. So we know atomic mass of nitrogen is 14, so 14 plus 3 into 1 is equal to 17 unit. Next, CH3OH. The molecular mass of CH3OH, atomic mass of carbon plus 3 into atomic mass of hydrogen plus atomic mass of oxygen plus atomic mass of hydrogen because here there is only one atom of carbon, 3 atoms of hydrogen, 1 atom of oxygen and 1 atom of hydrogen. We know atomic mass of carbon 12, then atomic mass of hydrogen 1, so 3 into 1, then atomic mass of oxygen 16 plus atomic mass of hydrogen 1. So after solving, this is 12 plus 3 plus 16 plus 1 is equal to 32 unit. Question 2. Calculate the formula unit masses of ZnO, Na2O, K2CO3. Here atomic masses of the following elements are given. Zinc Zn is equal to 65 unit, Na sodium is equal to 23 unit, potassium K is equal to 39 unit, carbon C is equal to 12 unit, oxygen O is equal to 16 unit. First, ZnO. The formula unit mass of ZnO is equal to atomic mass of zinc plus atomic mass of oxygen, and we know atomic mass of zinc is equal to 65 unit and that of oxygen is 16 unit. So 65 unit plus 16 unit because here only one atom of zinc and one atom of oxygen is present. So answer is 81 unit. Next, Na2O. The formula unit mass of Na2O is equal to 2 into atomic mass of sodium plus atomic mass of oxygen, because here there are two atoms of sodium and one atom of oxygen. Given atomic mass of sodium is equal to 23 unit and that of oxygen is equal to 16 unit. So 2 multiplied by 23 plus 16 unit is equal to, this one gives 46 unit plus 16 unit is equal to 62 unit. Next, K2CO3. The formula unit mass of K2CO3, 2 into atomic mass of K plus atomic mass of C plus 3 into atomic mass of O. So this is potassium, this is carbon and this is oxygen. In K2CO3, 2 atoms of potassium are present, 1 atom for carbon and 3 atoms of oxygen. Given atomic mass of potassium is equal to 39 unit, that of carbon is 12 unit and for oxygen is 16 unit. So putting the values, 2 into 39 plus 12 plus 3 into 16. So after solving the brackets first, we have 78 unit plus 12 unit plus 48 unit. Finally, after addition, 138 unit. Exercises. Question 1. A 0.24 gram sample of compound of oxygen and boron was found by analysis to contain 0.096 gram of boron and 0.144 gram of oxygen. Calculate the percentage composition of the compound by weight. Answer. Given mass of the sample compound is equal to 0.24 gram, mass of boron is equal to 0.096 gram, mass of oxygen is equal to 0.144 gram. To calculate the percentage composition of the compound, percentage of boron is equal to mass of boron divided by mass of the compound into 100. That is 0.096 gram divided by 0.24 gram into 100 is equal to 40%. Percentage of oxygen is equal to 100 minus percentage of boron. So 100 minus 40% is equal to 60%. Percentage composition of boron by weight 40% and that of oxygen is 60%. Question 2. When 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. What mass of carbon dioxide will be formed when 3 gram of carbon is burned in 50 gram of oxygen? Which law of chemical combination will govern your answer? Answer. First, let us write the reaction taking place here. C plus O2 gives CO2. Carbon plus oxygen gives carbon dioxide. As per the given condition, when 3 gram of carbon is burnt in 8 gram of oxygen, 11 gram of carbon dioxide is produced. So 3 gram plus 8 gram is equal to 11 gram from the above reaction. The total mass of reactants is equal to mass of carbon plus mass of oxygen is equal to 3 gram plus 8 gram is equal to 11 gram. The total mass of reactants is equal to total mass of products. Therefore, the law of conservation of mass is proved. Then, it also depicts that carbon dioxide contains carbon and oxygen in a fixed ratio by mass, which is 3:8. Thus, it further proves the law of constant proportions. 3 gram of carbon must also combine with 8 gram of oxygen only. This means that 50 minus 8 is equal to 42 gram of oxygen will remain unreacted. The remaining 42 gram of oxygen will be left unreactive. In this case, too, only 11 gram of carbon dioxide will be formed. The above answer is governed by the law of constant proportions. Question 3. What are polyatomic ions? Give examples. Answer. Polyatomic ions are ions that contain more than one atom but they behave as a single unit. Example: CO3 2 negative, H2PO4 negative. Question 4. Write the chemical formula of the following. Answer. A. Magnesium chloride MgCl2. B. Calcium oxide CaO. C. Copper nitrate CuNO3 2. D. Aluminium chloride AlCl3. E. Calcium carbonate CaCO3. Question 5. Give the names of the elements present in the following compounds. Answer: A. Quicklime, calcium and oxygen CaO. B. Hydrogen bromide, hydrogen and bromine HBr. C. Baking powder, sodium, carbon, hydrogen, oxygen NaHCO3. D. Potassium sulfate, sulfur, oxygen, potassium K2SO4. Question 6. Calculate the molar mass of the following substances. A. Ethylene C2H2. For reference, I have written here atomic mass of carbon 12 unit, hydrogen 1 unit, oxygen 16 unit, sulfur 32 unit, phosphorus 31 unit, chlorine 35.5 unit, and nitrogen 14 unit. Molar mass of ethylene C2H2 is equal to 2 into mass of carbon plus 2 into mass of hydrogen. We know mass of carbon is equal to 12 unit and that of hydrogen is 1 unit, and there are 2 atoms of carbon and 2 atoms of hydrogen. So 2 into 12 plus 2 into 1 is equal to 24 plus 2 is equal to 26 gram. B. Sulfur molecule S8. Molecular mass of sulfur molecule S8 is equal to 8 into mass of S, that is sulfur. Here there are 8 atoms of sulfur. So 8 multiplied by mass of sulfur. So we know atomic mass of sulfur is 32 unit. So 8 into 32 is equal to 256 gram. C. Phosphorus molecule P4. Atomic mass of phosphorus is equal to 31. Molar mass of phosphorus molecule P4 is equal to 4 into mass of P, because here there are 4 atoms of phosphorus. So 4 into 31 is equal to 124 gram. D. Hydrochloric acid HCl. Molar mass of hydrochloric acid HCl is equal to mass of hydrogen plus mass of chlorine. Here there is only one atom of hydrogen and one atom of chlorine. So 1 plus 35.5, that is atomic mass of chlorine, is equal to 36.5 gram. E. Nitric acid HNO3. Molar mass of nitric acid HNO3 is equal to mass of hydrogen plus mass of nitrogen plus 3 into mass of oxygen, because here there is only one atom of hydrogen, one atom of nitrogen and 3 atoms of oxygen. We know atomic mass of hydrogen is 1, that of nitrogen is 14 and for oxygen is 16. So 1 plus 14 plus 3 into 16. First solving the bracket according to board mass is equal to 63 gram. Friends, we have completed all the question answers from the chapter. If you find the video useful, kindly like it, and for any queries, kindly comment in the comment section. Thank you for watching.